Today we're going to learn how to find horizontal and vertical tangents of polar graphs. So in the first example, we want to find the horizontal and vertical tangents of r equals 2 minus 2 cosine theta. So the way you find vertical and horizontal tangents is very similar to the way we did parametric. So we know that our slope for a polar graph is dy d theta over dx d theta. So a horizontal line has a slope of 0. So in order for this to be 0, the numerator, or the top, has to equal 0. That is the only way that the slope is going to equal 0, and that's going to give me a horizontal tangent. The vertical tangent is when the slope does not exist, and that is going to occur when the denominator is equal to 0. Because if the denominator is equal to 0, then the slope does not exist. So let's find the horizontal tangents. So we're going to use the formula y equals r sine theta. We're going to go ahead and substitute the r into our r, distribute the sign, and then take the derivative with respect to theta. So the derivative of 2 sine theta would be 2 cosine theta. And to find the derivative of 2 cosine theta sine theta, we're going to have to use the product rules. Okay. So it's going to be the derivative of u times v plus the derivative of v times u. I'm going to go ahead and distribute the negative. Okay. So this is when we run into a little bit of a problem, because we have to set this equal to 0, okay, in order to find the theta that is equal to 0. But we have an equations in both cosines and sines, so what we're going to do is we're going to rewrite in terms of cosine. And the way you do that is you get rid of the sine by using the Pythagorean identity. So sine squared theta is equal to 1 minus cosine theta. So I'm going to go ahead and substitute that for my sine. Okay, I'm going to distribute the 2, combine my like terms. Okay, so I end up with this equation, which still looks really complicated, but now I have everything in terms of cosine. So notice that this is a quadratic equation, so I'm going to say let a equals cosine theta. Then I can rewrite this equation just exactly as I would a quadratic. I can factor out a -2, and then I'm going to factor using guess and check. So a is going to be -1/2 and 1. But remember that we did the substitution, so we need to substitute a back. So it's going to be cosine is equal to -1/2, and cosine theta is equal to 1. So theta is going to equal to cosine inverse of -1/2. So I need to find the angle where cosine gives me -1/2. So if I look at a unit circle, that is going to occur, cosine is negative in 2 quadrants, quadrant 2 and quadrant 3. So I want the x value to be the shorter side, so that's going to be 4 out of 6, or 2 pi out of 3. It's also going to be in quadrant 3, which is going to be 8 out of 6, or 4 pi over 3. So those are my 2 angles. And the only place that cosine inverse equals to 1 is 0. So those are the 2 places that I'm going to have horizontal tangent. I'm not done, because now I have to find the actual points. So what I'm going to do is, on the angles that I have, I'm going to go ahead and substitute it into the r to find the r value for each point. So cosine of 2 pi over 3 is -1/2, so that's 3. So the first horizontal tangent is going to occur at 3, 2 pi over 3. So this is in polar coordinates. When r is, or when theta is 4 pi over 3, I'm going to also have 3 comma 4 pi over 3. And when r is 0, I'm going to end up with 0 because this is, sorry, this is not 0. This should be 1. So 2 minus 2 is 0. Okay, so those are my 3 horizontal tangents. So now I'm going to find my vertical tangents. So remember, in order to find vertical tangents, I need to find dx d theta has to equal 0. So I'm going to find what x is. So x is r cosine theta. So I'm going to go ahead and substitute the r into my formula. Distribute the cosine. Find the derivative. Okay, remember that we're taking the derivative of the outside, so it's going to be 2 cosine theta times the derivative of the inside, which would be negative sine theta. Okay, we're going to set that equal to 0. In this one, it's a little bit easier to solve because all I have to do is factor out a sine of theta. So I don't really have to convert anything. I can just factor out a negative 2 sine theta. And now I have a product. So I can use the zero product property. Set them both equal to 0. So I'm going to have theta is equals to sine inverse 0. So what angle is my angle, what point is my angle 0? And that is going to be at 0 and pi. So then I'm going to add 1 or subtract 1 and then divide by negative 2. So cosine inverse of 1/2, that is going to occur in 2 quadrants. It's going to be in quadrant 1 and quadrant 4. So at quadrant 1, going to be 2 out of 6 or pi over 3. In quadrant 2, it's going to be 4 out of 6 or 2 pi over 3. Okay, so same like I did with my horizontal tangent, I need to find my points in polar coordinates. So I'm going to go ahead and substitute all my points into my r to find the point. So notice that the first point that I get is 0, 0. So remember that I had a horizontal tangent that was also at 0, 0. So I can eliminate this because it cannot be both vertical and horizontal tangent. So this is not a vertical or horizontal. So when I go back, it's not a horizontal tangent. So when r is pi, I get negative 1. So I end up with 4. So 4 comma pi. At pi over 3, cosine of pi over 3 is 1/2. 2 times 1/2 is 1, and 2 minus 1 is 1. So there's my second vertical tangent. And now I'm going to substitute 2 pi over 3. So cosine of 2 pi over 3 is 1/2. So 2 minus 1 is 1. So this, on all 3 points, is where I get vertical tangent. If you look at the graph of this, let's look at what the graph looks like. Okay. So we know it's going to be dimpled because when we get A over B, it's 1. So when it's 1, it's not a loop. Remember, it's only a loop when it's less than 1. It's symmetric on the x-axis and it's negative, so it's going to look something like this. It's going to go to the left side. So let's find our period. Our period is 2 pi and draw our graph. Okay, our magnitude is 2 and it's cosine, so it's going to go make a U, but because it's negative, that means everything gets reversed. So instead of it being at 2, it's going to be at negative 2. It's still going to be at 0, but instead of being at negative 2, it is now at 2. Still going to be at 0, and instead of being at 2, it's going to be at negative 2. So I end up with this graph. The 2 means that I'm going to go up 2. So I'm going to move all of these points up 2. Okay, so the purple graph is actually the graph of 2 minus 2 cosine theta. So at 0, my angle is 0. So I'm going to start there. At pi over 2, I'm at 2. At pi, I'm at 4. Okay, and it's going to be symmetric. So at 2, at 3 pi over 2, I'm at 2 as well. Okay, so you can start seeing, since I know that it's going to look like this, you can kind of see how it's going to look and draw the graph. Okay, so where we found horizontal tangents, if you remember, at 3, 3 pi over 2 pi over 3, and at 3, 4 pi over 3. We found 3 vertical tangents. Okay, so notice that when we draw the graph, it wasn't really exact. So let's draw our tangents first. So the first tangent was at 3, 2 pi over 3. So at 3, 2 pi over 3, I'm going to have, okay, so I'm going to have a horizontal line. Okay. At 1 over pi over 3, I'm going to have a vertical line. I'm also going to have a vertical line at 5 pi over 3. Okay. At 4 pi, I'm going to have another vertical line. And then at 2 pi over 3, I'm going to have a horizontal. Okay, so that kind of shows you how you would draw the graph. So you can actually get a little bit better graph and a better representation because you know those are going to be tangents. So that concludes today's lesson.